Hi everyone, welcome back to our YouTube channel. Today we are diving into a fundamental concept that powers blockchain technology, the Merkle Tree. Whether you are new to blockchain or brushing up your knowledge, this video will break it all down for you in simple terms. Ready? Let's get started. So, what exactly is a Merkle tree? Think of it as a data structure, a fancy term for how we organize and store information. A Merkle tree is a binary tree structure used in computer science and blockchain to organize and verify data efficiently. It's named after Ralph Merkle, the computer scientist who invented it. Now imagine a tree with branches and leaves. Each leaf in the Merkle tree represents a piece of data, and every branch combines the data below it into the one value. Ultimately, all this information is summarized in a single value at the very top called the Merkle root. Now, how does a Merkle tree work? Let's break it down. A Merkle tree is built using cryptographic hashes, unique digital fingerprints for each piece of data. Here's the step-by-step process. Step 1. Hash the data. Each piece of data called a transaction is hashed. A hash function takes input data and produces fixed length output like a unique digital signature. Step 2. Pair up and combine hashes. Next, these hashes are paired up. For each pair, the hashes are combined and hashed again, creating a new node in the tree. This process continues layer by layer. Step 3. The Merkle root. At the very top, you end up with a Merkle root, a single hash that represents all the data in the tree. The Merkle root is super important because it allows you to verify any piece of data in the tree quickly. Now, why is the Merkle tree important in blockchain? Let's try to connect the dots. Why does blockchain use Merkle trees? There are three key reasons. Efficient data verification. The Merkle tree makes verifying data incredibly fast. Instead of checking all transactions in a block, you only need to trace the hashes in the path leading to the Merkle root. This is called a Merkle proof. Data integrity and security. Since the Merkle tree is built using cryptographic hashes, even a tiny change in the data would produce a completely different Merkle root. This ensures data integrity. Scalability. Blockchains handle enormous amounts of data. The Merkle tree compresses this information into a single Merkle root, making the system scalable without sacrificing security or verification speed. Let's look at an example. In Bitcoin, each block contains thousands of transactions. All these transactions are organized in a Merkle tree, and the block header stores the Merkle root. When nodes validate a transaction, they use the Merkle root to confirm its authenticity without needing the entire data set. Cool? Right. Here's a quick summary of the pros and cons of Merkle trees in blockchain. Let's start with the advantages. Efficient verification enhances data integrity, reduces storage requirements. Now comes the limitations. Computational overhead for creating the tree requires consistent structure for proper functionality. And that's the Merkle tree in a nutshell. It's one of the unsung heroes behind the scenes of blockchain technology, ensuring efficiency, security, and scalability. What do you think of the Merkle tree? If you have any questions or want to learn more about other blockchain topics, drop them in the comments below. If you found this video helpful, don't forget to like, share, and subscribe to our channel for more deep dives into blockchain and technology. Thank you so much for watching, and we'll see you in the next video.